This unit is 4A, and I'm going to do the whole lesson in one video, so it's going to seem long, but only fast forward to the ones you need. Um, the first day, we're going to do basically being able to name triangles and draw triangles, and then we're going to discuss that the sum of the measure of the interior angles of a triangle is 180, and use that information. Start off with names. First of all, we're going to be able to name the parts of a given triangle. Obviously, we see that this is a triangle XYZ. We have to be able to name the parts. X, Y, and Z are vertices, so these three are my vertices. And each side is made of a line segment. So we've got line segment X, Y, line segment YZ, and line segment XZ. And then finally, there are angles that are here. Normally, we don't name angles using one letter, but since this is one triangle by itself, we can name the angles. So this is X, this is angle Y, this is angle Z. Now each one of those marks would indicate they're different in measure, but they don't have to be. Now if I start off and I discuss the sides of a triangle, there's special kinds of names and special kinds of triangles. First kind is the scaling. Now this picture here is drawing a scaling. Notice there's no marks, indicating we can't be sure that all the sides are equal. So that's how I know a scaling. Another way to do that would be to put marks. Now they can't be the same mark. So if I have 3 marks, 2 marks, and 1 mark, so that means each one's different. And then one more way to do that is to put lengths. I can make this length 3, that length 4, and that length 5. That would also indicate it's scaling because all 3 sides are not congruent. If they're not, all sides are not congruent, then all the angles opposite are not congruent as well, are not the same as well. Next type is the isosceles triangle. Again, this one's clearly marked 2 equal sides, but keep in mind, this one and this one are both considered isosceles. Isosceles can be a little bit tricky. It says at least 2 sides. That means it could have all 3 sides equal. So technically, both of these 2 triangles are considered isosceles. And finally is equal lateral. Lateral means side. So this means equal sides. And that's clearly indicated in this diagram here by the marks all being the same. Now, if we discuss angles, we've got acute, right, obtuse, and equiangular. I'm sure you've heard these before. Acute means basically all the angles are less than 90 degrees. This drawing here is the drawing of one. It's not very clear. This would be an example of an acute triangle. 30 degrees, 70 degrees, and 80 degrees. Notice they all add up to 180. 30 plus 70 plus 80 is 180, but they're also not the same. And they're all under 180, so they're called acute. Obviously, a right triangle has one right angle. It can't have more than one, because if 2 angles are rights, that means you have a total of 180 already. That means the other side can't equal anything. Now, an obtuse angle, this is an image of an obtuse, but to make this definitively obtuse, I'm going to name that big fat angle, the big one that's bigger than our right, I'm going to name it as 110. That pretty much indicates we have an obtuse triangle. Finally, equiangular triangle, equal angles triangle, they're all equal. Keep in mind, these 2 triangles will be the same triangle. If they have equal sides, then the angles are also equal. You'll be doing some multiple drawings on those kind of things on your practice assessment and then on your assessment. Now, these have 2 titles. One's going to refer to the angles and one's going to refer to the sides. I'm going to start with the sides. Since it's isosceles, so I want to make at least 2 sides equal. Now those 2 things, those equal parts I just drew, those are called the legs. This is called the vertex. Kind of weird. We use vertex in lots of different names. And then that one's called the base because it's not the same as the rest. Now, if I'm going to draw an isosceles and a right, the only place I can put the right is right there. Because these two sides, these two angles here and here have to be the same. Since in this case, this one's 90, that means those two have to add up to 90 to get a total of 180. So both have to be 45. An acute scaling. Well, that means, let's start with scaling. That means all the sides are not the same. So 3, 4, 5. But it also has to be acute. That means all the angles have to be smaller than 180. It doesn't look like my drawing here fits that because this one looks like it's bigger than 180. See how it's bigger than 90, I mean? So I'm going to redraw that picture. I'm going to try to make it so that all the sides and angles are not quite 180. So let's say that's 80 degrees. Let's say this one's 60 degrees. That makes this one needs to be 40 degrees. And it has to be scaling, so I have to indicate the sides are not equal to each other. Across from the 40 would be the smallest side. Across from the 60 would be the next biggest. And across from the biggest angle is the biggest side. There's a drawing of an acute scaling triangle. Equilateral, equal angular. Well, like I said before, if I have equal sides, the angles opposite have to be equal. So pretty much, there you go. Now, the sum of the interior angles, and it doesn't say interior here, but we're going to say the interior angles. So technically, this should say interior angles of a triangle have to add up to 180. So we can write an equation if we want to, or just take the two numbers that you get, the two angles they give you, and subtract it from 180. I'm going to get in the habit of writing an equation. I know that if I add up all of the angles, they have to add up to 180. Now I can do some simple algebra by adding like terms and then subtracting, subtraction property of equality, subtract both sides. I get the for x is 45. This one, same way. Add up the angles, they got to equal 180. X plus 120 is 180. And subtract, you get 60. Each time it's similar. Now I've got x plus 70 plus equals 180. 2 apples plus 70 equals 180. Now I'm just going to do my algebra. Subtract 70 is 110. Divide by 2 is 55. Last one. I've got to add them all up. I have to add 180, which allows me to say 6x has to equal 180. Divide by 6, and I get 30. Now, we could always ask you for the angles themselves. In this particular case, to confirm that this answer is right, we've got one is 30. We've got one that is 2x, which makes it 60. And we've got 3x, which makes it 90. If you add those all together, you do get the 180 that you desired. Okay, next day. We're going to discuss a few things. First, we're going to discuss angles like this. This is an equal angular triangle. If the angles are equal, we already discussed all three sides must be equal. Anytime the opposite two angles are equal or three angles are equal, the sides opposite are also equal. Another thing that's true about this one is if they're all equal, if all the angles are equal, then consider each one to be x, and that's a total of 3x has to equal 180. That means every angle has to equal 60 degrees. That's what we need to know about that particular 1. It's not stated that all the angles are 60, but because they're equal, they have to be. This particular triangle, of course, is right. So the question I'm going to ask you is, what must be true about B and C, the measures? Well, if all of them have to add up to 180, and this one's 90, that means the measure of angle B plus the measure of angle C has to equal, well, not 180 now because we took off the 90, which is right here. So that leaves us 90, which means we can actually call them something. We can say measure of angle B and C are called, what does it mean when they add up to 90? It starts with a C. Yeah, that's right, complementary. So anytime you have a right triangle, you got two angles that must be complementary. Now, there's a lot of things we can discuss in this one. First of all, if A is equal to X and B is equal to Y, because they both triangles have to add up to 180, what do you think is going to be true about C and Z? That's correct. Measure of angle A equals the measure of angle X, and measure of angle B is equal to the measure of angle Y. Then it must be true that the measure of angle C equals the measure of angle Z. Just a small thing about triangles. So what we're going to do today is we're going to discuss these exterior angles, the angles outside. So basically, if you extend one of the sides of a triangle, you form an exterior angle. So this side right here has been extended. Once you extend it, you create this exterior angle. Now, that angle and this angle are a linear pair. They have to add up to 180. But that green angle must also make these two remote angles equal to 180, which basically means this exterior angle, the exterior one out here, this angle, must equal these two added together. So basically you add your two remote interior angles, and it has to equal the furthest away exterior angle. Here's the example. Now, we don't really need to know some particular theorem that I just stated. This is the theorem that I just stated. We don't really need it, but it's very helpful in solving problems. Based on the theorem, this is my exterior, so you take the two remotes, which are the ones not connected to it, and they must equal. So X has to equal 60 plus, now I can't see the dang on thing because I covered it up, 50. So based on the theorem, we know that X has to equal 110. Not surprising, though. We know that the sum of the interior angles of a triangle must equal 180. So this one, and this one must equal 180. If that's the case, 60 plus the 50 is 110. Take away from 180, this has to be 70. Now, without that theorem, I know that these two angles here and here have to add up to 180. They're a linear pair, giving us exactly the same thing. X has got to be 110. Here again, I don't need this. I don't need this. The fact that the two remotes has to equal the exterior, I can use that. But this time I'm going to start with the fact that these two, this angle and this angle, have to add up to 180. So this one's got to be 180. So if I look at just the triangle, I can do what we did before and say all three angles have to equal 180. If you solve that, you will get 40 degrees. Now, if I looked at this in a different way and just used the theorem, then I would say the two remote exterior angles, remote meaning furthest away, those two have to equal its exterior angle, which is 180. Again, if I solve that, 100. So if I solve that, I get X equals to 40. Two ways to look at the same problem. And you can finish these two. If I am not mistaken, and I never am, you should solve this one. You should get, I don't know, how about 95? And here, if I solve this one, I should get x equals 150 degrees. Okay, you can confirm that. If you need some help, let me know. Now, this one, again, the idea here is used that the sum of this interior angles has to be 180. And then you know that there's a linear pair for 35 and y, or a linear pair. So let me just write the answers down and you can confirm to make sure you do understand it. This one is 75, and in this case, y will be 145. Here, x will be 80, y will be 100, sorry. Here, let's look at this one. Gosh, this one's a little bit weird. I don't know. This is hard. Uh-oh. Dang it. See these two marks? That means they got the parallel line transversal stuff going on. So I'm going to draw these two parallel lines. And if I look carefully, I see two transversals. Let's draw this transversal first. Look at these two angles. If you do your pattern, they should be equal to each other. It's a good thing we learned that stuff. Two parallel lines cut by a transversal, 45, 45, 45, 45. Great. I'm going to go ahead and erase this because I'm going to put that 45 in there. Now that I know this one's 45, I could probably tell you that this one's got to be, I don't know, how about 85? Because the sum of these three have to be, that's correct, 180. Finally, I can get y because this angle and this angle have to add up to 180. They're a linear pair. So 85 and 95 would create it. So here x is 45 and y is 95. This last one, again, note that there's parallel lines. I want you to try it yourself because this transversal here will help you solve this problem. Okay? And you'll also need the other one. If I do x, this one, x will be 40 and y will be 50. And let me know if there's any issues there. Pretty much what I just did is, I know this is 140. That makes this 40, 40. So this one's 40, 40. So I already know x is 40. Erase this. Look at your parallel lines, but this time look at your transversal here. We already knew that this one was 40, which means if I do that correctly, this is 90, so this one's got to be 90. So this one's got to be 50. On to the third lesson in this unit, which is polygons. Now, I know you've discussed polygons before. It's not a question. It's just a matter of us clarifying what you do and do not know. Polygons are made up of sides, just like triangles, because a triangle is a polygon. Each side is a segment, and you can name each segment. And there's vertices. Vertice A, B, C, D, E, and F. And there are also the angles A, B, C, D, and F. Notice that it's got to be closed. The figure has to be closed. And each vertice is the endpoint of the segments. There's no exceptions. Now, if you want to play around with these things, we all have these things called diagonals. That's anytime I take a polygon like we have here, and I draw a line connecting vertices. A lot of times they'll ask you how many diagonals do you have, and it's kind of annoying. You start with each one of them. There's 3, 4, 5, 6, 7, 8, 9. Total of 9. Hopefully I counted it right. If you take your time, you can get it. But all those green things are diagonals because they're not a side of the polygon. Things that are not polygon, this one. I mean, it's got this curve in it. That's not a segment. It's not a line segment. That's a curve. See this one? It's got this indentant in it. It cannot have these extra components inside. This one's made up of segments, but they don't meet at the endpoints. And this one clearly doesn't have lines for sides. Now, convex and concave, or convex and non-convex. Sometimes they call this concave. I'm more used to saying concave, but you can say non-convex. If you notice, there's no dents in any of these, but these guys, the concave ones, have dents in them. See the dent? And this one's got a bunch of dents where it goes inwards. These do not. So there's a difference. We just have to be able to name them in case we have to draw them. Memorized piece, triangles 3 sides, quads 4, penta means 5, hexa means 5, octa means 8. There's one in between called a septagon for 7, but we're not worried about that one. And then decagon, anytime we don't number the number of sides, we call it n, so we call it an entagon. Now each polygon, we're going to be able to determine 2 things. We're going to be able to determine the sum of the interior angles and the sum of the exterior angles. Now, exteriors are really easy. No matter what size, how many sides the polygon has, the answer is always 360. Now, the interior angles has a formula. If you take the number of sides n, say its triangle would be 3, then subtract 2 and multiply by 180, you get the measure of all the interior angles. Here's how this works. I'm going to draw a quadrilateral, which is a 4-sided figure. The formula says I'm supposed to subtract 2. This has 4 sides, so 4 take away 2, which is 2 times 180. The reason it works this way is because if I draw a diagonal, I've got 2 triangles. Each triangle has 180, so 2 times 180 is 360. So a quad has a measures of 360. A pentagon has 5 sides. If I take one vertice and draw the diagonals, I see I have 3 triangles. 1, 2, 3. Well, that's why the formula says take 2 away. A pentagon has 5, take away 2, which gives you 3 triangles. And each triangle is 180. So 3 times 180. And that works for all of the polygons. That's why the formula, and I'll highlight it because it's relatively important, and they're not going to give it to you on the test, is n minus 2. I always just remember the picture. So for a hexagon, interiors, there's 6 sides. So I take the interiors, I would say 6 subtract 2, because that will give me 4 triangles times 180. And then you multiply those 2 together. 4 times 180. Of course, I'm doing this in my head, not in a calculator. Ha ha ha. 720 degrees. Now the measure of the exterior angles, well, for any polygon, it's 360. That's easy. Number 2 is a decagon. Deca means 10. So 10. So the formula says just take 2 away, because that'll give you the number of triangles inside. So that would give me a total of course I'm doing this in my head, it's 1,440. Let me see, exterior angles is 360. It'll always be 360. Now this one has 1, 2, 3, 4 sides. I can visualize and see I have 1, 2 triangles, so 2 times 2 triangles is 360 degrees. What's the measure of the exterior angles? Really complicated, 360. Now this one has 5 sides. Now I could take the formula and just subtract 2, so 5 sides. 1, 2, 3, 4, 5. Or I could just say take one vertex, extend the diagonals to the interior pieces. It gives me 1, 2, 3 triangles. 3 times 180 is indubitably, without a doubt, 540 degrees. Now, if you get confused here, the sum of the exterior angles is 360. No, this is not a joke. They're always 360. And hopefully you can get that right on the assessment, because it's just a matter of just remembering that. Now what we're going to do is we're going to build on that a little bit. Obviously, we talked about the sum of all of them, And that's what we're doing here. But here we got to use the information we just learned. First step, one is I have to know how much all the insides add up to. This one is a 1, 2, 3, 4, 5. Clearly it's 5. It has 5 sides, so the sum of all of the angles must be 5 subtract 2 times 180, which, if you do that, you get 540. That's the first step. Step 2 is we're trying to find x. All those angles on the inside have to add up to 540. So 90 plus 90 plus 150 plus 160 plus the x has to equal 540. Now it takes a little bit of adding and subtracting, but we wind up with the correct response, which of course is, I'm doing this in my head, so 300, 490, 540 take away, I don't know, what did I just say, 490? I just messed that up in my calculator because I had a moment. 540 subtract 490 gives me 50. So x has to be 50. So there's 2 steps. One, figure out how much measure of the interior has to be, and then add them all up and get your value. So pretty much these are pretty much the same. This is a 1, 2, 3, 4. So the total number of the sum of all the angles has to be 360. And part 2 for this one, you will get 200, 260. You'll get 100. So the x equals 100. This one here, 1, 2, 3, 4, 5, 6 sides. 6 subtract 2 times 180. So the total number of all the angles together is 720 degrees. Now if I add up all the angles, x plus all of the angles has to equal 720. I'm going to get a magic number, and I hate to think what I'm going to get, and hopefully I don't mess this up. Taking my time. And I'm using my calculator. I'm subtracting all those angles. And I get x is 90 degrees. Now this one again is a 1, 2, 3, 4. It's quadrilateral. So 4 subtract 2 times 180 is the total number of measure, which is 360. Now I'm going to take the x plus the x plus the x. Wow. Let me write that again. X plus x plus the x plus the 60 has to add up to the total number, which is 360. And then you do some beautiful little algebra, and you get this, and you subtract 60 and divide by 3. You're going to get x to be 100. Now, one more thing. We've got these things called regular polygons. Regular polygons, all the sides and angles are equal. Which adds a new twist to talking about the interior and exterior angles. So right now, what we're going to do is we're going to write the key word here is each. Each interior angle, each exterior angle, not the sum of all of them this time. Well, we're going to need to know that. We're going to need to know the total of all the angles first. So the first thing I'm going to do is a hexagon. Hexagon has 6 sides. The number of the interiors, you would take 6 subtract 2 times 180, and you would get 720. That's all of them. And since this is a regular hexagon, I can divide that by 6 to get each angle, which gives me, and I'm totally going to mess this up because I feel like I'm going to do that, but I'm not. It's 120 degrees. That means each angle is 120 degrees because it's regular. And if I add 6 of those 120s, I get 720, which is the sum of all the angles. Now, This one's relatively simple. If you just remember that all of the exterior angles always, for no matter what kind of polygon, is 360. Now all I have to do to find each exterior angle is divide by 6 because there's 6 of them. So each angle is 60. So the same way works for all of these. If you first find the total. So for a quad, there's 4 sides. So you work that out and you get 360. So there's a total of 360 degrees in a quad. But there's 4 sides. So divide by 4, 90. Well, heck, if it's regular, it must be a square. 4 sides are equal. It means the angles must be equal. Therefore, it's a square. Hey, imagine that. Exterior. The exterior angles. Total sum is 360 divided by 4. That, ooh, wow, magic. That's also 90. Well, probably because it's a square. Pentagon. Pentagon has 5 sides. So 5 subtract 2 times 180. 3 times 180 is 540. Divide by the number of sides, 5, which would give me, I don't know, 180 degrees. I apologize. 108 degrees. My bad. So if I divide those two, you get 108 degrees. So each angle has to add up to 180. There's 5 of them, and you take 108 times 5, you get 540, which is the sum of all of the angles together. Again, exteriors, all of them are added up to 360, divided by how many sides is 5. That gives me 72 degrees. Kind of curious if you're noticing something about the two numbers. Just kind of curious if you notice that each interior and the exterior, there must be some magic going on. Just see if you're paying attention. 8 subtract 2 times 180 would give you the total number of angles, total measure of all the angles together. And I, of course, don't know what that is in the top of my head, so of course I'm not cheating, of course. I would never use a calculator because it's crazy. But I get 1,080. Divide by the number of sides, 8. And you get the measure of each angle is 135 degrees. Now, I'm going to guess what this one's going to be, because if you made any observation has been paying attention, what does these add up to? These two, the interior and exterior, interior and exterior. I'm just kind of curious if you notice a pattern. Let's see if it's true. So 360 is always the sum of the exterior angles. Divide the number of sides. Uh-oh. What's 360 divided by 8? 45? I probably could have figured this one out just by knowing this one. They all add up to 180. Check it out. Each exterior plus an interior add up to 180. So the final one is you're going to wind up with a total of 1,440 divided by 10, because there's 10 sides. Gives you each angle is 144. And then by the power invested in me, the exterior and the would be 3 to 6. Okay. Down to the last lesson. We've already discussed isosceles triangles. Isosceles triangle have 2 base angles and a base. The base angles are equal, but the sides opposite them must also be equal. So these 2 sides are equal. Those sides are referred to as legs, and the legs are connected by that vertex called the vertex angle. Now this theorem is what I just basically said, and its converse is also true. If the sides are equal, then the angles opposite must be equal. But if the angles opposite are equal, then the sides must be equal. That's called its converse when I switch the order, and it's true. So two sides are equal, then the two angles are equal. Or the two angles are equal, the sides opposite must also be equal. So how's that come into play? See here they're telling me the two angles are equal, but if the angles are equal, the two sides opposite must be equal. Now you're down to some beautiful little algebra. You get that. And if you solve it correctly, you get x is 6. Here, that means they're equal, which means if this one's 65, this one must also be 65. And you know that the triangles have to add up to 180, which will allow me to determine that x equals 50. Next one here, the two sides must be angles. The sides opposite must be equal. So 5x must equal x plus 20. And if you solve that one gingerly and carefully, you're going to get x equals 4. I lied. X is 5. So sorry about that. The next one, the sides are equal. So the angles opposite them must also be equal. So that's x. X plus x plus the 80 has to equal 180. If you solve that correctly, you should get x is 50. Uh-oh. Uh-oh. This looks like it's going to add some hard stuff to it. I don't know. I'm going to start with this number here, this 70. I know that these two sides have to be equal. So if I think about it, I've got two angles plus the 70 have to equal 180, which means two of them have to equal 110, which means both of those angles here are 55 degrees. So that's 55 and that one's 55. What kind of angles are these? Vertical. That one's 55. These two sides are equal, so the angles must be equal, so that's 55. And one more time, the angles of this triangle have to add up to 180. And if you gingerly do your math, you're going to get x is 70. Oh boy, this one, uh-oh. Dang nammit, they got those parallel lines again. Poop. Well, let's see. Draw your parallel line, take a transversal, and look at your pattern. 62, 62, 62, 62. That's pretty cool. Let's get rid of all that stuff. And I'm going to note that we said this one is 62. I'm going to put it in black if I can get the black marker to work. 62, which means these two are equal, so this has got to be 62. Now I'm trying to get x. I'm hoping that's 62, but let's see. Two parallel lines, cut by transversal, start with your 62, so that's got to be 62. Corresponding 62. X is 62. Takes a little bit of work and thinking, but you can't just rush your answer, but it took a few steps to get there. That's it. That's what the unit's all about. Please go through just a video of the parts that you need, and good luck on your assessment.